we are Memphis Communiversity, and today we are doing another Calculus Done Wrong lesson where we wrong calculus before calculus can wrong us. And today what we're going to be doing is we are going to be continuing our exploration on how to evaluate limits. And today we're going to be learning the most powerful way, the strongest method of them all, and that's going to be L'Hopital's rule. So L'Hopital's rule is a powerful method, and it's also not the hardest method to apply. I don't think it's too bad to do. Basically what you do is we're going to be taking derivatives. We're changing a hard limit question. We're going to take some derivatives and it'll become an easier limit question. And so that's really our goal here, as you'll see. Keep in mind that L'Hopital's rule was added to the AP exam officially, to the calculus, the AP portion, the AB form of the exam a few years ago. So it's one of the most likely things to be asked, and we actually want it to be asked. Even before it was added, anytime I saw a limit on the AB exam, I would try to evaluate that limit using L'Hopital's rule. So I feel like L'Hopital's rule is the best way to do limits. It's one of my students' favorite ways to do limits because it's so universal and it's not that hard to apply. So let's just see this in action. So L'Hopital's rule. So today, we're learning some fun. Because I'm a weirdo, throughout this video I might pronounce it La Hospital's rule because it looks like La Hospital. I might change it to a verb and call it look that tall. I might change it to a noun, L'Hopitalable. We'll just see how things go. We'll just see where this little video takes us. So let's get started. So what does L'Hopital's rule say? Well, it says that if you have a limit that is going to be an indeterminate form, and what do I mean by an indeterminate form? Well, I mean this. You have this limit. Usually our limits are fractions. And what it says is that if you have a limit where the limit is equal to 0 over 0 when you plug in the a, or infinity over infinity, these two things are called indeterminate forms, so we can call them indeterminate forms. So if you get this situation, then that means that you can apply L'Hopital's rule. So what does it say? It says that the original limit is equal to the limit of the ratio of the derivative. So you just take the derivative of the numerator, then take the derivative of the denominator, and you should get an easier limit. Limit of the numerator and then limit of the denominator. So it's a pretty simple process. Just take the derivative of the top, derivative of the bottom. You'll get a new limit. You still have to evaluate that limit, of course, but because derivatives are usually easier than their original function, that means that this question will probably be easier, and that's why we love L'Hopital's rule so much. A few warnings here and there. The first warning I have is that these aren't the only indeterminate forms found in calculus. If you're doing a college calculus exam, you'll see that there's other indeterminate forms. I'm only going to focus on these two, especially 0 over 0, because those are the ones that appear on the AP calculus exam, but hopefully you'll still find this useful if you are in college and you're watching this. So that's the first thing. The second thing is that while it looks like we have a fraction here, because we do have a fraction here, this is what a fraction is, just do not confuse L'Hopital's rule with quotient rule. That's usually one of my students' mistakes because you learn quotient rule, then you learn L'Hopital's rule, then you forget quotient rule, unfortunately. But let's try to make this straight. L'Hopital's rule is a limit process that happens to take derivatives. So you just take the derivative of the top, derivative of the bottom. So if you see a limit, you should not be doing quotient rule. You should not apply quotient rule. Do not do low d high minus high d low over low low. But if you don't see a limit, then it's usually just a straight up derivative question. Take a derivative of a quotient. That's when you do quotient rule. Low d high minus high d low over low low. You do not want to apply L'Hopital's rule to that case. L'Hopital's rule is a rule only for limits, so just keep that in mind. The second thing I want to warn you guys about is that when you have this limit right here, you still have to evaluate it, unfortunately. So there is a possibility, and we'll see an example of this, where you'll get 0 over 0. Well, what happens? Well, you just do the process over again. If you get 0 over 0, you just take the derivative of this now and the derivative of this now. So that will be the second derivative of the originals, but you don't really have to know that. So again, if you get 0 over 0, just keep L'Hopitaling until you get to an actual answer. One rule of thumb is that if you need to do multiple calculus processes back to back, usually it's easier to simplify that second quantity. So perhaps there's some constants that are canceling out, things like that. So if you need to take multiple derivatives, multiple L'Hopital's rule, eventually multiple integrals, it's usually good to simplify as you go, step by step. The final thing is that people take for granted that these fractions are going to be 0 over 0 because they're true like 87.2% of the time. Of course, I just made that set up, but it does come up very often. But you do want to actually verify 0 over 0, because if it's not 0 over 0, say you get like 0 over 5 or just the number 5, well then that's the answer. And if you L'Hopital, you might actually get the wrong answer. So again, you do want to verify you get 0 over 0 or infinity. Your math teacher might be trying to trick you. I like to trick my math students. But that's really my intro to L'Hopital's rule. The main thing is the derivative of the top, the derivative of the bottom. Let's get going. So this is sort of the process, not a very difficult process. Let's start off with some easier examples and then sort of make our way through some of the tricky stuff. So my first example is going to be limit as x goes to 2, x squared minus 4. Now what do we want on top? Let's have x squared here minus 2x. I believe we want plus 2. So this is going to be my first limit. Keep in mind that this limit, you can't do definition of derivative that we learned in our previous video because it's not of the right form, especially because of the squared, the a, and this doesn't match this. So we have to do something else. You could do pre-calculus topics, but we're in calculus. We don't want to use those baby topics. So let's try to do this with L'Hopital's rule. So the first thing to do in any single limit, is to plug in this number right here, take it nicely, and just plug it into all the x's and just see what you get. This should be a 3, by the way. Sorry about that. Before we start, that's key because we want to make sure that we get 0 over 0. So when you plug in 2 here, it's going to be 4. This is the worst 3 in the world. Let me just try to actually erase the 3 and not be lazy. So that's a 3. So it's going to be 4 minus 6 plus 2. That's going to be 0. Then we have x squared minus 4. 2 squared minus 4, also 0. We are good to go. We are ready to load that call. Fasten your seatbelt, friends. So what we're going to do is we're going to just take the derivative of the top, derivative of the bottom. We're not doing quotient rule. So just limit as x goes to 2. Because we got 0 over 0, we're going to be doing the power rule, of course. This looks like a pretty simple derivative. Looks like it's going to be 2x minus 3. And then on the bottom, it's just going to be 2x. And then again, when you apply the L'Hopital process, you don't get the answer straight away. What you need to do is you just need to evaluate this easier limit. Notice it is easier because derivatives are usually easier. So when we plug in 2 here, you'll get 4 minus 3. That's 1. And then when you plug in 2, you'll get 4 on the bottom. So this answer is 1/4. So again, not the hardest process in the world. Just notice how easy it is. Recognize that it's 0 over 0, and then take the derivative of the top, derivative of the bottom, and then plug that number back in. And that's all it is. So this is how easy it gets, but let's do slightly harder questions where we might mess up. So in our previous video, we talked about limits as definition of the derivative. So what's interesting is that some of my students never learned that lesson because they want a L'Hopital rule every single question. And you can actually L'Hopital all of those questions that we talked about in the previous video with the method that we're learning right now. So let's look at 2 limits from the previous video where we can actually apply the L'Hopital rule process because it's nice. So the first one I'm going to do is an H1. So it's going to be sine of pi over 3 plus h minus root 3 over 2 h. And then my next one I'm going to use is limit. We're going to do 2 at once because why not? We're pretty good. We can do this, friends. I believe in us. So the next one I want to do is limit as x goes to 2. On the bottom here, ln of x minus ln of 2 over x minus 2. So again, you could take this derivative using the method that we learned in the previous video. Identify the function that's cosine. Identify the a, pi over 3. Take the derivative of sine. You get cosine. I don't know if I said cosine, but the function is sine. The a is pi over 3. Take the derivative of sine, that's cosine. Plug in pi over 3, cosine of pi over 3 is 1/2, that's your answer. Same thing with this one. The a is 2, the function is ln of x. Take the derivative 1 over x, and then plug in that number 2. But again, some of my students like to do the same thing over and over and over again, and you can't blame them, so they want to apply L'Hopital rules to these questions as well, so let's do that. So first off, recognize that we do have 0 over 0. Because when you plug in 0, you'll get sine of pi over 3, and sine of pi over 3 is root 3 over 2. So what we're going to do is we're going to take the derivative of the top and the derivative of the bottom. Hopefully I won't run out of space here. Let's try to make this weird little line. Limit as h goes to 0. The derivative of the bottom is very easy. The derivative of h is like the derivative of x, which is 1. So that's not too bad. The derivative of sine is cosine. And then we're going to keep the same. And then we're going to multiply by the derivative of the inside function by the chain rule, but that just times 1. So we're good to go. Then we're going to plug in 0, because again, we're not done yet. We have an easier limit, but we still have to evaluate this limit. Let's attack this guy. When we plug in 0, you'll get cosine of pi over 3. Cosine of pi over 3, if you know your unit circle, is 1/2. So this is 1/2. The same answer we would have gotten, of course, if we did definition of derivative, because math works, of course. But notice the process isn't too bad. Same thing with this question. This question isn't as bad as well. You just have to be careful of one little thing, which I'll mention when we get there, because I like to help you guys out. So what's this answer, or what's this question? Well, we're going to plug in 2. We get ln of 2 minus ln of 2. Anything times minus itself is 0. Same thing with the bottom. So we are ready to lope that tall in this question. We do get 0 over 0. So just be careful when you're taking the derivative here. So we're going to write it over here. Let me just erase this to have a little bit more space. So you do get 0 over 0. So let's take this limit. So this limit, still the same number, x goes to 2. And then you just take the derivative of the top, derivative of the bottom. The derivative of the bottom isn't too bad. It's just 1, of course. The derivative of ln of x, not too bad as well. Memorize, that's 1 over x. This is the harder derivative, ln of 2. People want to write it as 1/2, and you can know why they want to do that. You can sort of imagine why they want to do that, because the derivative of ln of x is 1 over x. So why isn't the derivative of ln of 2 1 over 2? But just be careful if you're doing a L'Hopital rule of these questions, because the derivative of ln of 2 is actually 0, because it's a constant. What's the derivative of 5? It's 0. What's the derivative of 2? It's 0. What's the derivative of pi? It's 0. ln of 2, you can just type that in a calculator. You're going to get some decimal number with no x's, so that derivative is 0. If you avoid that trap, then the question becomes pretty easy. Again, what you want to do is you want to plug in the x to 2, and we get 1/2 by coincidence that this limit is equal to this limit. How fun. Obviously, that's a coincidence, but notice the process is pretty easy. Take the derivative of the top, derivative of the bottom, derivative of the top, derivative of the bottom, and all of these questions, just be careful of weird constants. The derivative of those is, of course, 0. So these are some definition of derivative questions that you can apply L'Hopital's rule. So what do we want to do now? Well, let's do a few more questions. Definitely nothing better to do right now than do some lope that tall questions. Let's just see some sort of stranger variations. So the first one I want to do is the limit as x goes to infinity of ln of x cubed over 5x. So this question right here, this is actually a question where you have limits involving infinity. So you could maybe do same heavy, top heavy, bottom heavy if you're very good at knowing how big certain functions are. But I would recommend doing L'Hopital's rule. You can still do L'Hopital's rule when you're going to infinity. So when x is going to infinity, we plug it into the top and the bottom. Notice that we get infinity over infinity, which, while lesser known than 0 over 0, you'll probably encounter this less. It's still an indeterminate form, and L'Hopital's rule is still applicable. So let's do that. This is just the limit as x goes to infinity. We're going to take the derivative of the bottom first because it's easier, and I'm going to try to build my confidence. So the derivative of 5x, that's just 5, of course. Then the derivative of ln x cubed. Be careful. We are taking derivatives. Please, 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 please. Anytime you're taking derivatives, you need to be wary of the chain rule. So what's the derivative of ln of x cubed? That's going to be 1 over x cubed. But you do need to multiply by the derivative of the inside, the derivative of the inside being 3x squared. So just be careful with that. Again, you need to be careful with chain rule questions. So let's try to write this as one single fractions. I don't like fractions within fractions. So I'm going to write this as 3x squared over 5x cubed. So we know we do have a new limit, a new L'Hopital rules question. So this is what I was saying a previous question, or in the intro. When you get to this easier limit, you could potentially get infinity or infinity again, because when you plug in infinity, you get infinity over infinity. So the thing to do is to do L'Hopital's rule again. But if you remember some sort of the tidbit, one tidbit is simplify this guy first and then check if you get 0 over 0 or infinity again, because potentially this question could be easier. So notice that if we do want to plug in, if we do simplify, x squared over x cubed cancel out pretty nicely. X squared goes away, of course. X cubed, you subtract 2 from the exponent, so this is just x. And then we're left with limit as x goes to infinity of 3 over 5x. When we plug in infinity, we're going to get 3 over infinity. So notice we do not have an indeterminate form. What is 3 over infinity? Well, if you saw our limits involving infinity video, you'll know that 3 over infinity is 0. Just imagine you have 3 things, you're splitting it up amongst a million people. Everybody would get a very, very tiny portion. Then think about splitting it amongst a billion people, a trillion people, a quadrillion people. I don't know any numbers above that. That's going to be 0. Eventually, everybody's portion is so small that it eventually tends towards 0, and that's what a limit is. So this answer is 0. So this question, I don't mind too much because it's sort of illustrating a lot of different things. Infinity over infinity is still a L'Hopital's rule question. When you're taking derivatives as you're doing L'Hopital's rule, of course, remember the chain rule, so that's why this 3x squared is here. If you want to apply multiple L'Hopital's rules, a good thing to do is simplify the question, and you might not have to do that. That happened in this question. Any finite constant over infinity is going to be 0, no matter how big that finite constant is. So a pretty good question and all. Let's do another one where we actually have to do multiple L'Hopital's rules. So I'm going to erase this. How exciting. We're just getting a lot of work done today. Always nice to be productive. So let's do this one. Spoiler alert, again, we are doing multiple L'Hopital's. So e to the 2x, I believe I want minus 2x minus 1. Then on the bottom, I'm going to keep it fairly simple. Let's just keep it as cosine of x minus 1. So let's just check if this is a L'Hopital's rule question. It is. So first off, what we're going to do is we're going to plug in 0. So when we plug in 0, e to the 0 is 1, of course. 1 minus 2 times 0. Sorry, I can't do simple math. But it's 1 minus 2 times 0. This goes away. So just 1 minus 1. We will get 0 on the top. That took a little bit more work than I expected, but let's keep going. When we plug in 0 here, cosine of 0, if you don't know on the unit circle, is 1 because the angle 0 corresponds to the point 1 comma 0, and you choose the x coordinate. So that's going to be 1. It looks like we are ready to lope that tall because we do have 0 over 0. So let's lope that tall. So what we're going to get is ln as x goes to 0. Let's take derivatives. The derivative of this bottom doesn't seem too bad, just minus sine x, because the derivative of minus 1 is 0. I memorized this, of course. Then the derivative e to the 2x minus 2x, e to the 2x minus 2x minus 1. Let's be a little bit careful. E to the 2x, I'm taking a derivative. I need to be wary of the chain rule. It's these small little chain rules that gets people. So what's the derivative of e to the 2x? It's not just e to the 2x, because that's the derivative of e. It's times 2 as well by the chain rule. What's the derivative of the inside function? 2. Then the rest of it is pretty easy. You'll get minus 2. So what happens when you plug in 0? Well, when we plug in 0, looks like we'll get e to the 0 again. E to the 0 is 1. 1 times 2 is 2, minus another 2. Then this looks like we are going to get 0 again. Then sine of 0, again, the angle 0 corresponds to the point 1 comma 0. The y coordinate is 0, so sine is 0. Sorry, I said the word 0 a bunch of times. I'm going to say it a few more times because we got 0 over 0. Oh no. Looks like we have to L'Hopital's rule again. No way to simplify this, so let's just get going. We're going to, if you get 0 over 0, just pretend that this is the new original question and just do it one more time. Limit as x goes to 0. What's the derivative of the bottom? Minus sine. Well, the derivative of sine is cosine, so we're just going to get minus cosine. And then this is probably the hardest part because the derivative of minus 2 is 0. again, don't forget the chain rule. You have the chain rule once, you're going to have the chain rule again because you have e to the 2x. So in multiple steps, this would be 2 times e to the 2x. This 2 is just rewriting this 2 because it's a constant times a function. But I need to multiply it by another 2 because I'm taking the derivative of e to the 2x. And what's the derivative of the inside function? 2. So I have to multiply it by 2 again. So notice 1, 2 came from the chain rule from the first load because rule step. And then the second 2 came from the load because, came from the doing again a load because rule. So 1, 2 from the first load because rule, 1, 2 from the second load because rule. If we had to do load because rule a third time, which fortunately we don't have to do, it would be another times 2. The derivative of e to the 2x is 2e to the 2x. Then the second derivative is 4e to the 2x, then 8e to the 2x, 16e to the 2x, and so on. But let's not worry about any of that. Let's just finish this question. When you plug in 0, you'll get e to the 0. Then you get 2 times 2, that's 4. Then we get cosine of 0, that's 1, just like from before. There is this negative in front, so it looks like my final answer is negative 4. So again, this is really the hardest it gets. Maybe it gets a little bit harder, of course, but just if you have multiple load because rule, it's going to be okay. Just apply it multiple times. We didn't simplify it because there's no way to simplify it, but if we could, we would have. And then finally, the chain rule. So let's do a few more questions. So one warning is that, again, if your math teacher is kind of tricky, then they're going to put trick questions because obviously the only thing that teachers want to see is for students to fail. So let's write this question right here. Limit of x goes to 0, x squared plus 1 times sine x. So I'm going to do this question right now. Basically, you do need to check that you get 0 over 0 or infinity, because if you don't, you're probably already done. So notice when we plug in 0 here, you're going to get 0. We talked about that in the previous question. That's because the angle 0 deals with the point 1 comma 0. 0 is the y-coordinate, so sine of 0 is 0. Then when we plug in 0, notice that we will not get 0 on the bottom. We could just get 0 over 1. So we're going to apply load because rule. What is 0? We're not going to apply load because rule. Sorry, I said the complete opposite of what we want to do. We didn't get 0 over 0, so we can't load that call, unfortunately. But it's going to be okay, friends, because we actually already have the answer. What is 0 over 1? It's 0. Load because rule are only for indeterminate forms. As their name suggests, indeterminate forms are answers where you don't know what the answers are exactly because they're indeterminate. This is not an indeterminate form. This is just the answer 0. We are done. So if you were to load because rule, you would actually get the wrong answer. Verify, please, that it's 0 over 0 before you move on. And it's usually pretty easy to identify that. So again, this is an example where a teacher would try to trick you and they're trying to make you do load because rule every single question. Just be on the lookout for these. Let's talk about a few more questions. I just want to do more chain rule questions basically because I think everybody misses the chain rule. So let's do one more chain rule question and then we'll talk about one more thing and we'll be good to go. So let's do this question right here. Sine of, let's see, what's my favorite number? 8x. And then what's my second favorite number? That's going to be 3. So we're going to do sine of 3x. So let's do this question. This question's a little bit different than the previous one, or a lot different than the previous one, because when you do plug in 0 here, we get sine of 0. We've talked about that a lot. You probably know sine of 0. I'm assuming sine of 0 is 0. So here we can load that call. Let's load that call one more time in the context of these questions. So the derivative of this function right here is going to be cosine of 8x. That's right, limit of x goes to 0. The derivative of the bottom is cosine 3x. But why did I just write blasphemy on the board? Well, I didn't remember the chain rule. Remember that these inside functions, you do need to multiply by the derivative of these inside functions. So what's the derivative of 8x? That's going to be 8. You can put the 8 in the front if you're feeling a little frisky. And then what's the derivative of the inside function on the bottom? Similarly, it's just the constant, so it's going to be 3. If you did not do the chain rule, you would have gotten the answer 1, but the answer is 8/3. Why is that? When you plug in 0, cosine of 0, as we said before, is 1, so the answer is 8/3. So please, 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 just remember the chain rule. Probably the most common mistake in my history of giving these math tests for teachers, or not for teachers, but for students when they first see L'Hopital's rule. So the last thing I want to do is maybe an easier question, but it's really only for the AP Calculus exam, both portions, the AB and the BC portion. So as I said before, in the intro a long time ago, this video has been way too long, but as I've said before, L'Hopital's rule was the last thing added to the AB exam as of the making of this video. Sorry, I can't speak. So you can expect that it's going to appear quite often, both in the multiple choice and the free response questions. Throughout this video, we've been writing 0 over 0, but for some reason, maybe, I don't know, they're weird or something. The graders of the AP exam don't like you to write 0 over 0, so they want you to do L'Hopital's rule in a very precise way. So what I'm going to do is I'm going to do L'Hopital's rule in what I call the Frick way, meaning on a free response question. If it's a multiple choice question, then do the question however you want to do it. You can write as much as you want or as little as you want, of course, because it's multiple choice. But on a free response question where they're grading your work, they do like you to write it in a certain weird way, which we're going to talk about right now. So basically what happens is they don't like to write 0 over 0 because that technically doesn't mean anything. So we're going to write it very precisely. We're just going to basically write sentences. So we have this limit right here. Let's do a very easy limit. Let's do x squared minus 9. And then let's do x squared minus, can't do any math today, 2x. What is that? 9 minus 6. So I think we just need to write plus 1 and we're done. Or plus 3. No, that's minus 3. Minus 3. Sorry, I didn't really prepare this, but let's get going. So again, this is the limit I'm going to do. I'm not going to do it the quick and dirty way. I'm just going to actually write out exactly what they want to get full credit, because sometimes these questions are worth 3 free response questions, and that's so many that I want to get all of them. So if you plug in 3 here, notice you will get 0 on the bottom, 9 minus 9. When you plug in 3 onto this, you'll get 9 minus 6 minus 3. That is also 0. But again, they don't want you to write 0 over 0. So what I'm going to do is I'm going to write it the precise way. So basically, I just say on the side, the limit of the top is equal to 0, the limit of the bottom equals 0. I'm not writing 0 over 0 because technically it doesn't mean anything. So I'm going to write limit of x squared minus 2x minus 3 is equal to 0, as x is going to 3. And then I write limit as x goes to 3 of the bottom is equal to 0. So again, this is just an annoying, fancy way to write 0 over 0. Instead of writing 0 over 0, I just say the limit of the numerator equals 0, the limit of the bottom equals 0. Then what you want to say is by L'Hopital's rule. Often good to state which rule you're using as you're doing the free response question, just to show them what you got in your tool belt. So by L'Hopital's rule, comma. And then unfortunately, if this question is printed on the page, you do need to rewrite the limit, and then you're allowed to take derivatives. So it's going to be limit as x goes to 3, x squared minus 2x minus 3 over x squared minus 9. So this is the original limit. Hopefully you can tell that that's minus 9. And finally, we can just apply the L'Hopital's rule process that we did in the previous questions. So instead of writing 0 over 0, I write all of this stuff, and finally I can take derivatives. Remember, as you're taking derivatives, don't forget to write the limit as x goes to 3. Sometimes that's a point on the AP exam. Let's take derivatives now. Looks like it's going to be 2x minus 2. And then this is just going to be 2x. We plug in 3. Plugging in 3, you get 6. 6 minus 2 is 4. We get 4 over 6, which is 2/3. So this is going to be my final answer. So let me just, this board is really messy now that I look at it, so let me just try to explain this to you. Again, on free response questions, if you see a L'Hopital's rule, do not give in to the temptation to write 0 over 0. Don't be lazy like I am. Write this precisely. So you have this original limit right here. What you do is you write the limit of the numerator, limit of the denominator, show that they're both 0. Then you actually state the rule by L'Hopital's rule. You have to write the original limit, then you write the limit of the ratio of the derivatives, take the derivatives, and then finally plug in the number. So in the previous questions, we were just going straight from here to here after we verify that it's 0 over 0. A little bit more work, of course, but it's all just tedious work. It's nothing too hard. Just writing limit right here, limit right here, limit right here, limit right here by L'Hopital's rule. And that concludes our video. Hopefully you got something out of this. I would try to do L'Hopital's rule for as many limits as I can see. You'll see that it's a very universal process on the AP exam. Anytime you see a limit, it could potentially be L'Hopital's rule. In the future, we'll even do further limits when we learn other topics like differential equations, and you'll see that in differential equations, you could have a L'Hopital's rule question. You could have L'Hopital's rule questions from graphs even. So it is going to be pretty universal, and it's very important. Try to master it for now for these more basic examples. And just remember the small steps that we talked about earlier. Sometimes you have to do it twice. If you do it twice, you might want to simplify. You do want to verify that you get 0 over 0, and of course the chain rule. It is such an important process that it's understandable if you want more practice for this. If you do want more practice, of course we have a Girls Teach Calculus video. I'll link that in the description or below, where one of my former students runs through many of these questions, sort of trying to avoid the pitfalls that we talked about today, those non-0 over 0 cases, the chain rule cases, multiple L'Hopital's rules, etc. Sometimes I think as many as 4 L'Hopital's rules. So be on the lookout for that. That girl probably explains things better than I do, so check that out. But thanks again for watching. In our next video, we're going to actually recap the previous 3 videos, sort of as a group. It's going to be just limits review, and we're going to be talking about L'Hopital's rule, which we talked about in this video, also limits involving infinity, and limits as definition of derivative. But until then, thanks again for watching. Like and subscribe if this was useful for you, and I hope to see you in that limit review video. Thanks again.